you like to start?
Yeah.
Great. Okay, so. Okay. Yeah. So it's my pleasure to welcome Dr. Volker Fischer, who is going to give a talk on titled Research and Development at EML, European Media Lab, Speech Technologies. So Dr. Volker Fischer studied computer science at the University of Erlangen-Nuremberg, Germany. He received his diploma degree and his PhD, Dr. Ing. degree with a thesis on parallel image understanding from the same university in 1989 and 1995, respectively. From 1996 to 2007, he was a R&D staff member at IBM's European Speech Research Group. In 2007, he joined European Media Lab Speech Technology GmbH and became EML's research manager in 2017. Focused scientific interests comprise aspects of multilingual speech and language processing systems. He is the author of one book, author or co-author of several book chapters, and more than 50 reviewed papers, and holds 6 patents in the fields of speech recognition and synthesis. Volker is a member of Germany's Gesellschaft für Informatik and in the International Speech Communication Association, ISCA, IEEE, and the Program Committee of TSD. So we welcome Dr. Volker. The platform is yours, Volker. Thanks.
Well, thank you, Matthew, for the kind introduction. I learned that it is still too long, but you need to put a long life into 3 sentences. And I would urge all of you to leave away the doctor, because in my career, I learned that once you have it, it is no longer important. Anyway, today I'm going to talk about research and development at EML Speech Technologies. We are located at the university campus in Heidelberg. Here you can see the building in which we occupy 1 floor. For those who haven't been in Heidelberg, it's quite in the center of Germany. Some people say it is a suburb of Frankfurt, so it's close to the airport. But yeah, I don't believe so. I think it's a quite beautiful city. Matthew has already said everything about me, I guess. So I'm working here on speech recognition and understanding since 2007. I did so before in IBM, where I was working also on then time concatenative speech synthesis. And yes, in late last century, I was working on image analysis and got a PhD from University of Erlangen-Nuremberg. I'm not talking about image analysis. I was young and needed the money, let's say it like this.
Okay, sorry to interrupt you. I just was wondering if you have shared your slides by any chance.
You don't see my screen? Is that what you're saying?
No, yeah, I think it is.
Sorry. Oh, I'm sorry. Yeah. I forgot it. That's too many windows open error, I think. You now see it?
Oh yeah, good.
Yep.
That looks good. Thank you very much.
Let me see. You now see it larger? Yes, very good. So this is what I talked about. You didn't miss anything important. The overview of my talk, I'm going to introduce EML and say a few words about our products, and then I will review some past and current research projects we are doing at EML, and I will finally spend some words on challenges where we participate, which are not in the form of a funded project. So EML was established in 1997 as EML European Media Laboratory. It was at that time, it was a non-academic research institute privately held by Klaus Tschira and his family. He is one of the founders of SAP, Europe's largest software company, I believe. And until 2007, there was a broad area of, or a broad range of topics which were pursued, among them bioinformatics, geoinformatics, but also things like natural language processing and also scientific databases and the visualization of scientific results. In 2007, that changed, and from then on, the only focus was on speech and language technologies. We are pursuing a couple of or many languages. We like to do multilingual recognition, and during that time, it has been quite interesting to do speech recognition because it was the time when there was a transition from traditional Gaussian mixture model, HMMs, to nowadays deep learning, recurrent neural network, HMM based, and also beyond. I will talk about that a little bit later. And we also focus on, say, assorted technologies that our customers require or find useful, namely speaker diarization and language identification. In 2018, the company changed owners and became EML Speech Technology. And at the same time, we partnered with a Munich-based company, LinguaTech, who is the leading provider of speech solutions for the office domain in Germany. Our product portfolio, we are developing scalable real-time speech technologies. We'll come to that in a minute, and we try to keep it based on state-of-the-art academic research. We have a couple of main products and services. There is, on the one hand, the EML transcription platform, which we will see on the next slide, that is used in applications like speech analytics or also media transcription. There is a local decoder, which is intended to run on smaller devices, for example, in a car, in a smart home environment, or things like that. We still see and do believe that language technologies work best if they are customized to particular use cases. And for that purpose, we also have web-based customization tools that we use internally and also sell to our customers. Namely a language model workplace that allows you to, I will come to that in a minute. Okay, and for the same reason, because we believe in customization, we are also doing education and in these language technologies, how to use the tools, best practices, and so on. And we provide services in this area. And I think we have done that which might be interesting in TAPAS, we have done that also for a couple of topics in medical speech processing for, I think, Parkinson and aphasia and also Alzheimer. I think if you want to know more about that, you can ask Julian, who has used our tools. He was one of the first victims, I guess. the EML transcription platform that is a scalable software that converts audio into text. It comprises of several components we will see on the next slide. And here we have the applications like, for example, dictation of voicemail. We have speech analytics which is interesting in call centers if it comes to, say, questions about what are the current topics handled by the agents, or what is the overall customer satisfaction, and so on. And well, another thing is, for example, broadcast news transcription, where you transcribe media data, for example, for subtitling, but also to make it searchable in larger archives. Yeah, and here we see how our customization tools come into the game. So we here have a language model workplace that allows you to download text resources from the network of, say, from a customer relation management system, and it then allows you to either create a language model out of it that is then deployed to the transcription server and used for this particular customer, or you can also use it for language model adaptation. And that is where the services or human interaction comes into place. And there is another thing, which is the transcription workplace, which is used to transcribe audio and to manually transcribe audio. And if you have the correct text, you can use it for language modeling again. We can also use it for the correction of recognized text. So everything that is processed here by humans is usually pre-transcribed with an ASR system. And this way we can enlarge our database of transcribed audio that is then again used for building our, say, acoustic models. The transcription server itself, please don't ask me a lot of details about that. There is a lot of Java programming in it, like a queuing system that gets an XML-based description of where to pick the audio. The audio is then queued in a queuing system. Here we have a piece of software that listens to the cues, which sends it to the correct decoder at the core of the platform. This and sends out the final results. The decoder itself, that is a C++ piece of software, and the main features for the time being is that in addition to transcription, it supports online diarization. I should add here online language identification as well. Of course, we are doing deep learning. We are using vocabularies and language models of up to 1 million words. And of course, we need to have all the models memory mapped so that they can be shared by many instances of the decoders. The local decoder, you get all this, you get the same piece of C++ code as a decoder, but not all the surrounding things or software for job management and so on. The local decoder is focused more on speech interaction. So input is audio and output is text together with an action. And this way you can for example, do convenience control in a car. So here we have a collaboration with a company that builds cars for handicapped persons so that they are able to drive. And of course, you can imagine that voice control for the non-critical interactions in driving are highly welcomed by those handicapped peoples. Data at EML, we have a lot of public data, which is either free for research, or we need to license for commercial use. This is the foundation for building our models, but it is also true that the best data or the best results you always get if you use an application for data collection, the target application. So we are running a couple of services where users can use our products, for example, for transcription of voicemail or so. Here we always need the user's consent in the, don't know the English term, it's the conditions under which you provide the service and do the business. We have data from customers or partners that we use to improve either our models or only some of our models. That is the difference between exclusive and non-exclusive use. And you need to clearly separate these data so that you do not use data from partner A for building a model for partner B if you are not allowed to do that. And that you need to do this although the data is usually already anonymized before given to EML. Well, and then there is other data. For example, if we have a customer in the medical field who cannot give out the data, we do transcription, manual transcription in that case to make the data usable on customer premise. So in that case, the customer, the company would buy or install one of the transcription workplace, and then our transcriptionists, students log into it and transcribe the data on the customer premise. And there's data that is temporary and not even backuped, like, for example, the data that one ESR in TAPAS brought to us. That was a French corpus of pathological speech, and this data is removed as soon as it is no longer needed for that particular purpose. Coming to the core of my talk, which is research and development activities. What you see here is a list of, or a chart of past and present EU-funded research projects. And here we have a couple of past and present national funded research projects. So in translation, and we do use these projects usually to get some of our efforts in the enhancement of technology to get them paid by the funding agency, say EU. So here we have Translectures, which is long done. That was a project on the transcription and translation of video lectures. We did the transcription part, and this gave us the opportunity to change from the HMM based, to change from plain MFCC features to neural network feature extraction, but the modeling in the acoustic model was still based on GMMs and HMMs. Then came Listen, that had to do with voice access to web applications in a smart home environment. It suffered a little bit that right after the project start, Alexa was announced, but at that time, we had the distinguishing feature that we were running on very small devices in the user's home, so privacy preserving. Then we had Tensor, which gave us the opportunity to enlarge our language portfolio by Arabic. So Tensor was a project in the field of public safety, where safety agencies like police or so, they were interested in transcribing Arabic speech, among many other data processing. And please notice how I managed to put TAPAS on top of all of them, although we are not doing any research in TAPAS, but we are doing exchange with the community by hosting ESRs. And that would certainly have been worked out better without the COVID pandemic, which all of you are suffering in your work as well. So here we have the national funded research projects, which I'm going to talk about in a bit more detail. We have Coffee done, and we have two more, Pegasus and Adaptar, in all of them in very different fields. And I think I will start with a Coffee project. Coffee is for cooperative interaction between driver and vehicle, which is the car, partners from 3 universities and three industry partners. And it was about highly automated or semi-autonomous driving. The goal of the project was to design a human-machine interface that make people trust in the technology of autonomous driving, because in cases of emergency, they have to rely on that technology. For the very same reason, there was a quite strong legal and ethical supervision. I think I mentioned it here because it was the first project where we had such supervision. I think, in short, the two questions in the project boiled down to who is responsible if autonomous driving goes wrong? That is the legal supervision. And I think the answer was it's always the driver. And then there's the ethical supervision, which boils down to the question, should the automatic driving system minimize the damage for the driver or for the pedestrians around him or outside of the car? So this is, I think, a quite, how to say that, quite important question if it comes to the acceptance of autonomous driving. Our tasks in Coffee dealt with robust ASR for voice user interface for a dialogue system. And the idea was also that that we provided, based on the spoken words, provide additional insight that into questions that the dialogue was interested in, namely, who is driving? Is it a male or female, young or old? Is the people used to the technology or not? Then there was the question, is the speaking style a regular one, or can we do we have any hints that the driver is nervous or things like that? They were also interested in the current driving scenario. Is it a takeover maneuver? Is it the start of a journey? Is it on a regular highway? Things like that. And finally, it was also the question in multi-intent utterances, is a multi-intent utterance that is something like turn down the music and pass the car in front of us. And in that is a multi-intent utterance, and it was about finding out the more urgent task in such utterances. The outcome, so, of coffee. On the one hand, we were able to enhance our technology from the tandem models I mentioned from the trans-lecture scenario to which was all offline and speaker adaptive, to a real-time speaker independent long short-term memory hybrid system. And we achieved more than 90% word accuracy, and the dialogue system done by one of the industrial partners achieved a 95% task completion rate on that. All the other questions that we were supposed to ask, they suffered a lack of training data. So we were not able to distinguish any person from another person in terms of these, say, demographic terms like age or gender or so. In the question of, is the speaking style a non-regular or a regular one, we also suffered from little data, but at least we have been able to identify out of the scope utterances. For example, imagine you have a big company where you do data collection within the project, and some of the your colleagues who willing to participate, they do some poem reading or are not cooperative. And at least by the approach that was taken for all of these questions, we were able to identify those out of scope utterances. By the way, at that time, all these classification tasks were not done with neural networks, but it was in that case a method called latent semantic mapping, which is based on the singular value decomposition of word co-occurrence matrices. For the driving situation, this seems to have a pretty dedicated vocabulary to the vocabulary dedicated to the situations. We were able to differentiate the 6 classes with almost 88% success. And the work on multi-intent utterances, that was not finished when we left or when we finished with the project, and the partner doing it extended his time in the project at no cost, and I think it resulted in a PhD thesis, but unfortunately I haven't heard much of it since then. So after these rather mixed experiences here with and quite frustrating experience with having no data, I promised to myself I will never participate in a project that has no data. And having said that, there was the next opportunity, which was Pegasus. Pegasus is in the field of combat against organized crimes. It has to do with, or has to deal with, heterogeneous data. And again, here we are providing ASR. So, I mean, step one. The key question in protection from organized crime is who, when, where, and what. To answer these questions about suspects or possible suspects, the project tries to identify cross hits, which are similar terms detected in heterogeneous data in different records. And for the speech part of it, we are working on speech recognition over the mobile phone or in-car surveillance. And there's also a legal and ethical supervision in this project. The one thing here is that no task-specific data, training data is available, and that we, if it is available, it might be the, if it comes to a certain case with a judge, the judge may say you are not allowed to use it. So the idea here was to simulate conversations between suspects and then use synthetic data to do acoustic modeling. So there are several end users, police departments in the project who have some experience how these conversations between suspects look like. We have partners who create a chatbot that will simulate these conversations, and we then synthesize them and train acoustic models on this. And the details you can see here. So we have the lingua tech text to speech, where we have for the time being 4 different German voices, and to make it more robust, we use a noise database and randomly add noise to it, to the synthetic data. And of course, we use the simulated conversations also for language modeling. Now, because this is also the simulation is ongoing work on the one hand, and also because it is affected by the pandemic, we have to create a preliminary showcase, and that is, we said, hey, EML, we are good in voicemail, so we will try to create a voicemail recognition without voicemail data, only following this approach here, plus some public data, and then we'll compare it with a gold standard that has a lot of our voicemail data in it. And here we see the result. So let me start at the bottom. That is our gold standard. All our public available data like speech.car, Verbmobil, a couple of other sources, plus EML collected voicemail in the acoustic model and in the language model, and we end up on that particular maybe difficult test set with 20% error rate. This is what you see here below, the 19.9. And if we leave away all the data we are not supposed to use in the project, then we have only publicly available data, speech.car and Verbmobil, pretty old data, I might add. And we have more than 50% error rate without a language model support of voicemail, and almost 50% error rate with language model support of voicemail. And then we took the Verbmobil data and created synthetic speech out of it and added the synthetic noise to it. And here you can see the development that we had, and the current best one is right now here. So it is 31.4, and this almost, or this reduces the gap, the initial gap from here to here by, I think it's more than 50%. So it looks quite promising, but we, of course, we need to verify that once it comes to the quite spontaneous and special conversations between suspects in crime cases. So I learned that they have a particular vocabulary. They say things like daisy, which is a small flower, if they mean some drugs and things alike. But fortunately, we only need to recognize daisy, and if they are talking about drugs or not, that is other partners' business. Then finally, the final running one is, I'm looking at the clock, okay. We have Adaptar, that is a project that has to do with digitalizing the industry and reducing cost in the creation and adaptation of technical instructions for the entire product life cycle. And the basic idea is that you have an augmented reality environment where you as a worker can first look at the product and can this way learn about it, and also that it is maintaining the that by AR the technical instructions itself are improved. So the call itself, I was missing these words, but here they are. It is about innovation for tomorrow's products or production services and work. Yeah, we want to reduce the cost for the creation and maintenance of always up to date and user-friendly technical documentation. Besides augmented reality, another key concept in the project is the so-called digital twin, which is a big database that collects every fact about a physical product during its lifetime. When it was built, what has been repaired, who did it, things alike. And the products we are considering here, they range from dishwashers to complete steel mills, and high precision lasers. So there are 5 end users in it who all have their own ontologies and vocabularies and so on. There's also legal supervision in this project where they care mostly about the workers' health and safety. Excuse me. So what we are doing in this project is we are defining, or we are creating hands-free input for interaction with the system, with the augmented reality digital twin system. And we took this system as an opportunity to do first steps in end-to-end ASR. And as another topic, we choose to do voice activity detection for shop floor conditions. Let me say good morning to Elmar. End-to-end processing, I'm sure most of you know about it. You have an input audio, then you have an encoder who compresses everything to a single embedding or state let's say in an embedding of the input. You then decode it, and at the end you create an output. So the input can be, for example, a source language or an audio frame. Then you here have a representation of the input sequence, and the decoder creates a sequence in the target language, or it creates, in case of end-to-end speech processing, it creates letter output or sentence pieces or things like. These systems are quite successful these days, but it is also true that they work best if if you use tailored recipes and system architectures for particular tasks, like, for example, LibreSpeech, Switchboard, Wall Street Journal, or Timid. So as soon as you start to do a kind of cross-validation, meaning that you, for example, you put your LibreSpeech test set into your switchboard system, you will see that results start to degrade. So what we are seeking here, because also the domains are so different, we are seeking a common training recipe and model architecture that ideally is also usable for other projects that we are doing. We have chosen the Espresso toolkit as a framework for this. Since we yet do not have domain adaptation data and therefore may have weak representations of the input here, we are also looking into domain adaptation, again with synthetic data. And we also need, if we want to make a product out of this later or deploy end-to-end in our products, we also need additional features, like we need word boundaries that are required if you do, for example, search in audio. So we need the time marks. We also need time marks for the correction of dictation output. We can, back to here, we cannot wait until the entire, presumably long audio sequence is encoded into a representation because we need to do streaming. And finally, what is very annoying to users is if say the letter or sentence piece output is condensed into something that is a non-word. So we took this system or this approach to create a Dutch system, and we, in the output, I spotted the word Dammeltrump, which I don't think is a Dutch word, and it might describe the person very well. What was meant here or was spoken here is Donald Trump. So having this in a transcript that you provide to a customer will be very annoying to him. So there's preliminary output. The interaction concept in this project, the interaction with the augmented reality and the digital twin is not finally defined. We achieve a 85% task completion rate on preliminary and clean data recorded by only 2 speakers here on our side, no shop floor conditions. And the potential of the approach is seen in the fact that we already outperform our word error rate for Dutch, which is a language where we have only little data, where we not have phonetic expertise, but where we already beat with this end-to-end approach, where we already beat our best so far system. The voice activity detection, we developed a voice activity detection, which we tested in the Fearless Steps 3 challenge for this year's interspeech. I will come to that in a minute. Yeah, research challenges. Why do we participate in public evaluation or battles with academia? We do so to benchmark our technology, to get new ideas, of course, and ideally, or what we like in particular, if we can reuse the data provided by the organizers. I think that was the case here in the, no, it was the case here in the Spanish broadcast speaker diarization task. So what you see here is that we participate only in challenges where we have a need to develop or enhance the technology, so because our customers want to use it. So 2 times we have participated in speaker diarization challenges. We have participated in 1 language identification challenge that was about Oriental languages, very confusable. I think there was Korean and Malay and Japanese and so on in it. Short utterances, which makes the task even more difficult. And yeah, with the voice activity detection, we developed in Adaptar, and we'll come to that back to that in a minute. We participated in this year's Fearless Steps challenge, where we used the same algorithm with the recordings from the Apollo, I think it was Apollo 11 space program. Let me say that all these tasks in some sense are signal classification tasks. And for this, we came up with a GMM-DMM hybrid system for signal classification. I'm not going too much into the details, but here you see the common front end. So we start by creating a GMM, unsupervised GMM from MFCC, and use that to automatically label the training data. And that gives us some acoustic labels. And here we have the respective labels from the challenge, which in that case here are speech, non-speech labels, but which could also be speaker or language labels. And so what we basically then have is classes like, this is speech from Gaussian number 17 in this UBM. So the labels, the unsupervised acoustic labels and the provided labels are here combined. And then we do some context. We do, of course, LDA. We create other contexts. We transform the data again. And that is the input data to the classification system itself, which is again a combination of GMMs, which we have here. We do adapt the GMMs with the data created by the front end. And then we put first order statistics into a DNN to create embeddings for the respective case. So either speech silence embeddings or language embeddings or speaker embeddings. And finally, we end up with prototype vectors for the particular case that are then subjected to a decision logic, to a cosine measurement during runtime. Actually, in case of the fearless step, which needs to distinguish only 2 classes, namely speech and non-speech, we saw a little improvement from deploying the additional DNN here. So the embeddings created by this DNN do not help a lot in speech, non-speech detection. They do help in speaker diarization and also in language identification. Our goal here is to basically to have the same system for any task, and only so that we do not need to implement that much software in our product, and to handle the different tasks just by parameterization of the respective modules. In these recent challenges, now that we compare to others, a special thing for us is that we also need to, that we always compare accuracy and latency. In accuracy, we usually rank among the top 30, sometimes 40% of all participants. We usually provide the fastest system, and in some occasions we are the only ones providing an online system. Online means that you start to do the decision based on incomplete information or audio. Out of the language identification challenge, we have meanwhile created a new product, a language identification toolkit, where we hide this complexity here under a graphical user interface, and customers, most of them in the public safety domain or business, can create their own models and run with our engine. They can create their own models on premise on their platforms. So this was the outcome of the voice activity of the Fearless Step Challenge. So the challenge baseline, this is the big bar here, 12.5 or 15.6 on the eval. Our baseline algorithm from 2018 ended up with 5.14, and our submitted system ended up with 3.8. That gave us number 4 in 6 competitors. But we are, say, closer to the third or the second one, and have a quite good, have a quite good margin to the fourth one. And we do have the fastest system among all the competitors. So are we happy with this result? I think we are. Back in my IBM times, I learned a saying about these competitions, which was that the second place, this guy here, second place is the first loser. And I increasingly start to not believe in this saying, because we are doing, we are gaining a lot out of the participation in these challenges. And this is basically all I had to say about research and development at EML, in a small and medium company, in a small company actually. The thing is that everything we do in research is more or less is more product driven, and we think that we always get good improvements or enhancements of our products out of it. And with that, I'm already done, like my voice is done, and want to say thank you. And I want to say sorry that I cannot make it the entire day, but if there are any more questions than you are supposed to raise now, just send me an email and I will be happy to discuss. Thanks a lot for your attention.
Thank you, Volker, for the interesting talk. So let's open the platform for questions, please.
Yeah, thank you very much also from my side. I think you have very interesting projects. I was wondering whether you could tell us a bit more about the ethical and legal supervision you mentioned for some of your projects.
Well, I think that is something that started, at least in the area where I am, it started roughly with the coffee project in 2016, and it is these days, or it stretches out to many aspects of a project. It starts with data collection and doing experiments. For example, in the coffee project, there was a driving simulator that is say a moving chair, and you see a video surrounding you that simulates driving situations, and some people can, including myself, get sick if presented to such as, or if they are in such a scenario. And every experiment, every data collection that was supposed to be done in this project had to go through an ethical advice where doctors at the conducting university or a committee at the conducting university looked into the experimental setup and said, well, it's potentially harmless, so you can do it in this setup. Another thing that we are very much debating in the Pegasus project, where we have these analysis of heterogeneous data, of SMS text data, of messenger data, of speech, of geo-tracking of mobile phones and so on. And all this analysis is nowadays done in neural networks. And the question here is the technology just, is it fair, or are there any parts of the population that it is biased against? So to put it blunt, are all the criminals from Heidelberg, and or are Heidelberg inhabitants more often suspected by the system than others? Is it righteous with respect to color, or color of your skin, of course? And these are questions that are in this project. I was about to mention another one which escaped my mind. In the Adaptar project, it is more about labor unions and so on. They want to be asked and have to be asked, in my opinion, if it comes to introducing new technology in production, in companies and so on. Question here is it safe for the people using it? Will it set free half or how many persons of your workforce will it set free, and will you have adequate other jobs for them? These are all ethical and legal aspects that need to be proven, and where we have partners in the project doing it.
Great, thank you.
Any other questions? So if others don't have a question, I have a question for Volker. So it's an interesting point. We can start from the last one, speech activity detection. About. So what is, how do you determine, for example, to what level your speech activity detector has to work for an application? Because we always don't have an absolutely good speech activity detector.
Neither we have. I mean, this is probably something that is not an aspect of this challenge, because in this challenge you just compare the labels on the dev or eval set with your output. And in this challenge, the decision cost function that is written here in small capitals, that says that a false negative is 3 times costly, more costly than a false positive, which is reasonable for the for this scenario of the Apollo 11, because if Houston does not hear you, Houston does not hear you. So you better have a false positive, I think. In our own applications, when we use, we do use VAD for segmenting the input of our audio. Do we need to recognize something or not? And I think a good indication is we are most of the time we are trying to get away from or to get rid of too many insertions errors. And you know, all any task that you try out will give you a different baseline error rate dependent on the conditions, but in my opinion, it always you always can benefit if you roughly balance the deletions and insertions. And that is how we usually set our voice activity detection parameters. Maybe there are side or other conditions like processing time.
Yeah, so that's another question, right? So so what kind of latency it will introduce, because we you know, the whole GMM, DNN, all those things, and how much latency does it introduces, you know?
Well, this system here for the fearless step that runs in 0.002 real time. So this is, I would say, no latency, or almost no latency. And the thing here is that, or in all our challenges, we have a particular activation function in the DNN, which is the variational rectify linear unit, VRELU, which allows you to, up to a point, compress the DNN into a single matrix, into a single layer. And that gives you an additional benefit if it comes to speed. So these DNNs, they are not very deep, I would say, on itself. That it is, I don't know, maybe 4 or 5 layers, and sometimes we find that we can take that we can extract the embeddings from layer 3 or so. But due to the additional runtime optimization that we multiply out all the activation matrices into one matrix, we gain additional speed during runtime.
That's an interesting. And so in your application, this is a more practical question. Do you adapt your VAD dynamically? For example, the threshold or something.
Yes.
It's not sure that it will work on single threshold all the time.
Right, we do either model adaptation or threshold adaptation.
Okay.
Both of them. We do that also for speaker diarization if it comes to the question whether to create a new identity or model during runtime, or a new, let's say, a new speaker prototype during runtime. And in my opinion, there are always too many thresholds or parameters in the runtime, but you know how it is. Cannot get rid of all of them.
Does anybody else have further questions? Otherwise, I have more questions for So the question, the further question comes is, you were talking about this encoder decoder architecture for things, right? So today they talk about RNN transducer, you know, which is more suitable for streaming applications and all those things. How would you? What is your take on that point? That's
if it is more suitable for streaming applications, I would.
Yeah.
I read about it only. I would certainly look into it. Thing here is you have to start with something, and in the adaptar context, we are supposed, or we handle the case that we have a voice interaction system, so rather short commands. And since we have to start with something, we started with what was available in this particular Espresso toolkit, which is this architecture, either based on LSTMs or on LSTMs with attention mechanism, or in a more transducer-like way with feed-forward nodes or networks only. Yeah, as I said, we are taking first steps towards products, and unfortunately, I would say today there is a paper on neural networks written every 20 minutes worldwide. So you never know where to find the silver mine or the golden bullet or whatever.
That's interesting. That's in one more question I have for Fabric. Give you someone else if they have some more questions. So EML has gone through various technologies, right? HMM, GMM, hybrid systems, and then now we are having end-to-end and all those things. So when you are changing these technologies and all, you know, what's the effort, you know, you need to move into new things, maintaining them? How do you see this? This is something which is not obvious to many people. You know, it's not always easy to just take a big architecture and everything, implement and run it and make it perfect that it works for an application and all those things. Most often our research paper stops at on some data set we evaluated and we do that. So how much effort and what kind of other challenges one faces in this kind of scenario?
Well, I think one big challenge is to make or to put this into a stable, reproducible framework that can be used by basically all of us, all of my colleagues, our customers, if they want to. And we must be clear that we rather give away a % in accuracy than you know, creating something very special that will take us say 3 person-months or so. But
so was it a big difference for when we moved from HMM, GMM systems to, you know, hybrid neural networks and all those things?
Yes, it was.
It was a big difference, I would suppose.
Yeah,
right?
I mean it's. But no, what I'm saying is, imagine we are using BLSTMs, and imagine we have no gated recurrent units. Now, they are, we have them, but we do not use them. We know they are roughly the same in accuracy and speed, but for say 1% difference in word accuracy, I wouldn't implement it in our runtime decoder because the effort is too big, unless someone comes and has a real demand. So of course we are making these decisions based on customer input, but there are certain lines that we do not want to go behind, right?
Okay. So that is an interesting question. If anybody else have a question, I have one more question on top of it, which you raised up in this discussion. Anyone else have a question there?
It's yours, Matthew.
Okay, this is my interesting question, because the reason I'm asking is because every time we publish a paper, we always look at performance improvements all the time, and we say, oh, this method gave me some this percentage of absolute or relative improvement and so on, and we keep trying different architectures and all this stuff. And in industry cycle, you just pointed out that you always decide upon the effort. You need to, you decide upon the effort and what the value it will bring in. Right. So it's an interesting experience. So how this experience, like a young researchers can take from their work, because for paper publication, sometimes we are just looking at numbers. Sometimes, what is the performance and so on. So how to think about value part of it? I'm asking the question from that perspective. How much value these things will bring in, like if I move from JRU to some other network or this network and so on. So what would be your advice on that?
I certainly appreciate all this work that is done on, say, particular tasks, in particular challenges on optimization that is done in the academic world, because I think this is driving the technology or science forward. All I'm saying is that outside of the paper publishing business, let's say it like this, there are different, how to say that, you have to make, sometimes you have to make different decisions that take into account other aspects like the cost of implementation. If you read a paper, the first thing, in my opinion, that you should do is, or from my experience, you should do is, how will it translate to my data, or how will it translate into my case, or what is the, how about real-time behavior? This is not mentioned in too many papers who try to tweak word error rate. And well, I think this is an advice that I could give if it's not already obvious to all of you. And if you are working in industrial research and development, over time, you will learn more of, learn to know more of these aspects that you need to consider. One big question is always, if a customer comes with dreaming about AI, do you have the data? Can we do it? And in Germany, I think we are not in the quite good position that we can download large language models from Hugging Face and just start working on it and do publications on it, because nobody presumably has the data. or it's very well hidden to EML.
Yeah. Well, yeah, because that is the question one will face, right? Let us suppose, as you said, there is like not so deep networks, it works, but then people will be asking about fancy networks, right?
Right,
So
right.
then the question arises most often how to convince even a client, you know, coming to you saying that, hey, this is sufficient for your problem. This
is absolutely right. I mean, expectation management, customer expectation management, that is something you need to do carefully, very carefully.
Good. Any other questions? Some other things from the discussions? Okay, if not, I would like to thank on behalf of all of us again, Volker, for this interesting presentation about what research and activities going on EML, and sharing insights about all the details, how they go about, and thanks again, Volker, for things for the nice talk.
Welcome.
And any other questions, please feel free to write to Volker directly, and I'm sure he'll respond to your questions.
Right. Thank you.
Thank you. Again. Thanks, Volker. That's good. Zhao, you can stop the recording, I guess. Yeah. So the next talk we have is from Felix, titled Emotional Voices in Human-Computer Interaction. A short biography of Felix is that Professor Dr. Felix Burkhardt does teaching, consulting, research, and development in the working fields, human-machine dialogue systems, text-to-speech synthesis, speaker classification, ontology-based natural language modeling, voice search, and emotional human-machine interfaces. He is currently a full professor at the Institute of Communication Science of the Technical University of Berlin. Since 2018, he is the research director at Audiering. Before that, he has worked for Deutsche Telekom for 18 years. Originally an expert of speech synthesis at the Technical University of Berlin, he wrote his PhD thesis on the simulation of emotional speech by machines, recorded the Berlin Acted Emotions Database, EMODB, and maintained several open source projects, including the Emotional Speech Synthesizer, EMOFIT, and the Speech Labeling and Annotation Tool, Speech Analyzer. His research interests are human-machine dialogue platform architectures, ontology-based semantic modeling, emotional human-machine interaction, automatic speaker characteristic classification. I invite again Felix to give the talk. Felix, the platform is yours.
Yeah, thanks a lot, Matthew. That was nice. And I will actually talk exactly about what you just introduced. So let me share my screen and share sound. I hope this will work, but it should. So you see my slide? Yeah. Does it work?
Yes.
Some feedback. Okay, cool. So I will talk. I mean, I know that you talk about pathological disease here mainly in TAPAS, and this is perhaps a bit different then, but I try to relate it to this topic too. And as I worked most of my life in emotional speech, so this is actually what I can offer best, and I'd like to present to you this. First, I'd like to start with an introduction, another one. I know you already got one. Now that's an outline to the talk. So I will introduce you to emotional modeling issues, explain some experiments I did, like the ones that you just talked about, Matthew, then finish with some challenges and opportunities. So I started actually quite late. I know I don't look like it, but I'm pretty old already. And when I was in my 30s, I did the A levels actually. Originally, I'm a children educator, but then I wanted to become a musician, and then it was all too cumbersome. And then I thought, let's be a phonetician and computer scientist. So I went to the TU Berlin and did that for some years, did my PhD there on emotional speech synthesis. And then in 2000, I joined Deutsche Telekom for about 18 years. And then, so about 3 years ago, I switched to auditing, which was a great idea actually. And since last year, I have a provisional professorship at TU Berlin, and you can all press your thumbs that I get the job, but up to now it's only until they find the real professor. So the job is open, you can apply actually. My working fields are mainly speech, emotional speech, actually dialogues and semantics. That's something that I worked on in the telecom times, and I was always have been interested in this. This little box here is a computer that I gave as a present to my father when I was 6 years old. Oh, so cute. So who needs voice? That's this slide is kind of old, 20 years old, I guess. So I guess not many people still would wonder, why would we need a voice? The internet is becoming more and more pervasive. Mobile devices become smaller or bigger. I mean, smartphones get bigger, but implants, for example, get smaller. Home mediation trends, all these smart speakers around us, we need to communicate. Typing and looking at monitors is not always a good thing. So what is the most natural interface? It is actually gestures, but that's just a little joke. I mean, it is true that pointing something is much more natural than saying something, but this talk is about voice. This is just, I really love the books by Yuval Harari, and I would really recommend reading them, but I guess most of you have already looked into that. So the history of Homo sapiens is rather old, but more than 200,000 years, and only for a short part of this period, we even gained cognition, which gave us a big gave us an advantage to other homos like Homo neanderthalensis and like this. So why do I say this? Just saying that lots of us is still pretty animalistic, and we still communicate a lot more with grunts. This has a much longer history than actually the Industrial Revolution or all the clever stuff we try to say now. And I know that Albert Mehrabian is criticized for many reasons, but if only half of what he says is true, and I think we all know this from our daily life, what you say, how you say it is way more important than actually what your words are. Yeah. So, and of course, Mehrabian pointed this more to body language because this was his specialty, but it's also true for voice, for speech. The voice reveals way more than the words. I guess this is the right audience here for this. So more or less directly, because it's physically related, stuff like sex, age, social act, dialect. I mean, the physical relatedness, of course, here is not very straightforward, but it is there. Health, definitely. Personality, there's actually a new study from psychologists that I read in Süddeutsche Zeitung just yesterday. They found out that F0 is is related to personality and to sexual activity. Sorry that I find this funny, but you know, we study this stuff, and also psychologists, but also speech scientists, of course, since many decades, and it seemed a bit simplistic. Mood, relationship, weight, length, that's also body size, index masses, that's that's clear. But even stuff like heart rate is detectable from sustained vowels. Yeah. So and you can hear the heart bumping in some experiments. What is not revealed, what's not there, cannot be detected. So, for example, color of hair, something that's not. I mean, some people believe that AI can do everything, but then I guess most of you will agree with me that AI is just a clever word for marketing. So it's all statistics, and what is not in the data cannot be detected by the data, but can only be induced, but not deduced. So this is to be kept in mind always with a grain of salt, with who says what. So I guess you will be familiar with this project here, speech to face. I'm not sure if it comes from Stanford, MIT, somewhere in the US. And they built this large net giving you a face to a voice, which is based obviously on who was in the database. They had using a large database of voices and faces. And this is a great example for bias, I think, because if you come from a group of humans who was not in the training, then your face will never be, not nearly any be detected. Or it will not be likely. By the way, I forgot to ask, how much time do I have until 12:30, 11:30? Is that correct?
Yeah, yeah. The session goes up to around 12, but we get the talk call 11:30, 11:45.
Oh,
Yeah.
okay. Oh, that gives me
would be
lots of time.
perfect
Thanks.
for people to question and discuss with you, Felix. Thanks.
Very cool. That gives me lots of time. I like that. Because you see here, I really start kind of from the scratch. So AI and emotions. I mean, this talk is more for lay people too, but might give you some ideas. Emotional behavior and intelligence is not only related. It is in a way that's one and the same. I mean, it depends on your definition of intelligence, obviously, but there's many examples that it's not possible. So it is part. Emotions are part of intelligence, right? So because it helps you to decide quicker, faster, and yeah, just saves time, and it is part of your body, as is intelligence. There's many experiments. So if you change your body, like for a sickness like encephalitis lethargica, or via an accident like what happened to Phineas Cage, there was this this iron piece that he holds in his hand went through his head actually, and destroyed among other things the amygdala, and it's changed his personality and also how he behaved, intelligent or not. So enterprise is not correct. Yeah, it's you will not be more logic if you are less emotional. That doesn't make sense at all. I really like this citation, though it's a citation from someone else. Everyone except the psychologist knows what an emotion is. And that's one of the reasons why these categorical emotions are so come so handy, because everyone understands them. Yeah, everyone knows what is. I'm angry. I hate you. I'm happy today. Stuff like this. And I really love this movie Inside Out from Pixar. Like all Pixar movies, but that's a especially great one. And it manifests the big five emotions in the brain. It's really fun movie to watch. So if you didn't, please do. This is, I think, they're easily recognizable. This is anger, fear, joy, envy. They stole this from Ekman, I guess, and sadness. These are the emotions, and to see not only by color but also by expression, you can mimics expression, you can, and body posture. They really nailed it. So the emotions, usually I said that categorical. There's the big four or the big six or whatever emotions, going back at least to Charles Darwin. And there's many experiments around this. So anger, joy, fear, and sadness is what is meant to be culturally universal, and perhaps this has actually not been said by Darwin, but by a predecessor of him, might be important for evolutionary reasons, like if you don't detect fear, then you might get eaten by a tiger, stuff like this. And if you don't react appropriate to your other humans' expressions, then they might kill you, and you will not procreate. So this might be a reason why this is universally recognizable. Things like Paul Ekman and also Darwin went around in the world and showed pictures to people and asked them, so which emotion is displayed here, and they could recognize that. Same goes actually for for speech, but in a different way. So from mimics, I guess there's many experiments tend to show that dimensions like valence are better expressed in, or more clearly expressed in facial expression, and arousal in vocal expression. Okay, there's some more researchers that I really think they did great work, so I'd like to introduce them here in case you don't know them. Plutchik is the one with this flower picture of emotions, and he created something, a theory like a color theory for emotions, where you have secondary and primary emotions, and you can mix them and they can contrast with each other. And Panksepp, he researched on common emotion in animal and man, like Darwin actually, and he found that the same. So he introduced 7 primary emotions like fear, anger, lust, mating behavior, stuff like this. And not only did he find them in cats and humans at the same time, but they were also located in the same areas in the brain, which I think shows how old our brain comes from evolution. Yeah. So when cats and human common ancestors, I guess, already had these emotions. That's how I would explain this. Okay, so to the big 4 come 2 more by Ekman, Disgust and Surprise. And to me, this is more because they are easily recognized from the face, I guess, because Ekman really did lots of, he's the one who described facial action coding system, stuff like this. Then going further from categories is the dimensional space, and one well-known possibility here is a PAD, pleasure arousal dominant space. Of course, you can locate categories in this space. Famous, I mean, to me, most famous was Schlossberg in the 50s, actually introducing this, but it goes back way further to Wundt and even to the Old Greek, actually. Aristoteles, Platon. So this is quite old, but useful, very useful, especially for engineers. So if you don't want to model all these categories, you can just take some dimensions and then try to place new categories or find categories, even with unsupervised learning, find categories in your data and trying to place it in these dimensions. I think that might give some idea to interesting experiments. First time I think of that, actually. Okay, so here's Klaus Scherer. He was talking actually just the day before yesterday at my institution in TU, and the talk is online. I think that if you never heard Klaus talking, then you're welcome to do so. And if you're remotely interested in emotional speech, you really should listen to Klaus, because he wrote all the foundation papers in the 60s. And it's on YouTube. Appraisal models. So this is competent process models, and it was not invented by Klaus, but goes also way older, like Spinoza and even older. But I think makes a lot of sense to model an emotion not as something magic that is there or happens or something, but is a process to an event that happens to you in several stages, like novelty, pleasant, goal, coping, and then norm compatibility. So this is really meant in this order, yeah, in time. These are the checks, and then you can model how they would affect the muscles and affect your way of speaking. That's something that we did with Klaus together. So we being audiering right now. VOC Emo API, it's patent pending. And the what I find rather useful with this model is that you can model why it is that, yes, emotion is culturally universal in a way that it can be detected or categorized over cultures from different humans around the world, but in various degrees. So the farther they are away the culture, the more different it is, the more difficult it is the less high the accuracy is between encoders and decoders. And I think this one explanation might be that this is heavily filtered by culture. Yeah. So what are you allowed to show, and how is it interpreted in the end, the raw signal that comes out of the animal that we still are. Okay. So now I'm slowly coming to stuff that I did actually during the last 25 years or so. Something I did with Anton. You all know Anton, I guess. So we were thinking about what can we do, what can computers do with emotion, and we wrote a little paper on that, which we actually just extended together with Björn now on ethics, taxonomy, applications that utilize emotions. So you could just mediate it, you can recognize it, you can simulate it, you can model your AI with it. And yeah, going further, I mean, you could model humans as being emotional, but then we get quite philosophical. So in the end, I mean, of course, there's a continuum between these things, yeah. But I find that interesting. Then being at Telecom, of course, we thought about applications, and Telecom has quite a lot of interactive voice response systems, so voice portals. And we asked ourselves, how can we? Okay, given that we can detect anger, for example, in a voice portal, which is a classic case, what do we do with it? And that's actually not straightforward at all. So there's a paper on that for some strategies. Here, Markus Balegoy was a psychologist actually. But most of this, the machine, at least in those days, were lacking the intelligence, and I think it still is. So, yeah. Telecom used anger detection more for statistical use cases. So looking at the end of the day, how many of our customers were angry today, and is it perhaps related to some event that happened, stuff like this. One thing that is quite unique to stuff like emotion as a signal or as a target feature is that it is totally undefined, not measurable really by any physical measure that I would be aware of, like centimeters or so, or degree Celsius. But usually, to be honest, we never even look at emotion. We ask other people, what do you think, how this person feels? And that's a kind of worms, a box of Pandora that's really very difficult, because most of the cases, not even the question is clear. So are you asked how the person feels inside, or how the person would like to feel, or how I feel if I listen to the person, and all this is really difficult to really understand. So actually what we did at Telecom usually is that we did some training sessions with the annotators, and this is also done at the Deering, so to try to get them more on one level, yeah, that they really annotate the same thing, because otherwise, I mean, this is for machine technology, and machines get confused, of course, if not even the humans are confused. I mean, the good thing is that you can measure this. There's one thing before I come to this is what is an emotion is also can be subdivided, of course. So that was one master thesis actually done at TU Berlin, where I thought, well, okay, we looked at anger, but this anger is very different. And I asked myself, can we subdivide this anger? And yes, it was pretty easily possible. I mean, Max Schmidt is not this Max Schmidt here, another one. He wasn't very experienced, but he quickly found out that he could distinguish based on some Shearer taxonomies for other subcategories of anger, and they also could be so they were attributed by labelers consistently, and they also had distinct acoustic features. I guess it's not surprising, but it's still keep this in mind if you work with emotions, that it's just a word and it's not clear what it actually is. Because how good can we be? That's especially with marketing people or management people. Sometimes they forgot. They say, why don't we have 100%? That shouldn't be so difficult. Or some companies promise 100% or 99% or 98%, like for ASR. But the difference to ASR is that there you have a clear measure and a goal, and you can be superhuman. But with emotion, human is the ceiling. And of course, you can construct some superhumanness by having kind of the best humans, whatever that would be, the ones who agree most with each other, I guess. And then agreeing a bit more, stuff like this. Yeah. But in the end, something that's called Bayes error, I got this from Andrew Ng actually, is the lowest possible error rate that you can have for a machine classifier. It's a human's performance. And that's also not always regarded. So this is about labelers not being consistent, and you can sometimes you really find labelers like labeler B and C really agree a lot, 80 kappa value. Kappa goes from 0 to 1 for being related to random by totally being the same. And others like B and say E do not agree at all. So this is kind of a weird situation here we had in a real project. We did actually I worked some years with the W3C, so not as an employee, but in this group with Debbie Dahl actually in the multimodal action group, and we did, based on Mark Schroeder's work, a standard on our recommendation called emotion markup language, where we try to get a formalism for this, how to describe emotions, in case that hasn't been known. And this doesn't only deal with categories, dimensions, but also appraisal theory and action tendencies for robots. But I will not have the time to go into this. This is a bit of walkthrough through my life, actually. So, of course, I have to mention the emotional EmoDB. It's a very, very full-blown emotion database that you can get for free, and since a long time. And it made me very my age index is mainly based on EmoDB, I think. And so I love this database. No, I don't think it's very valuable for emotions, because I don't believe that full-blown actor portraying emotions, that's something I call the Disney effect. Of course, you can produce recognizable fear by shouting loud or something in a high-pitched voice, but that doesn't mean that people who really are afraid would utter something like this. So, but you can use it as a test, and I think if you can't make it there, then you have a problem with more realistic databases. It's 6 emotions. Yeah, I can skip that. EmoDB, as I said, the emotion is portrayed very clearly here. We can test the audio actually. This is a happy sample. Is it working? No, not for me. That would be really sad. You cannot hear anything too, right?
No, we cannot.
Me neither. Why not? That makes me sad. Is it possible now?
Could it be when you share the screen that you didn't click?
Yes, I
share
did.
the sound. Oh.
No, I did, and then even I think it's related to this Zoom. No, that's really a shame. I think we have to, looking at the time, we have to go without the audio samples. I will test that next time. There are quite a few of them. I derived some rules from this database. So that is what my PhD actually was on. So I have quite a lot of data on that. So it was recognized. This is some actors from the database, and they were recognized in a listening experiment. Well, recognized. It was a forced choice listening test. So they could say which emotion should be which. And actually, the rule-based synthesizer wasn't worse than the individual actors, as you see here. Actually, more balanced. Then for a long time, I worked with Forman synthesis. So this was my this is this Forman synthesizer here. It constructs speech from filtering. Filtering some impulse stuff here, and that's actually everything. So you can synthesize speech with about 200 lines of C code. I found that really very impressive. Yeah, Dennis Klett, he gave this code for free 40 years ago in a journal called JASA, JASA, and I really love the synthesizer and used it during my PhD. And I'm not really away from this. So I still think, well, could I use deep learning to learn the formats that need to be driven for the synthesizer? So I could have a hybrid synthesizer. It wouldn't sound very natural, but who says that robots or machines need to sound natural? I wouldn't agree. Actually, they should be understandable, but not perhaps natural. But they should be able to express emotions, and that's pretty easy done with a Forman synthesizer because you have so many stuff that you can work on here that you can influence. That's then some synthesis results that I got. So that's a confusion matrix, and you see that 9 emotional states were distinguished from each other. Especially worked on voice quality based on Dennis Klett and John Laver's work, and yeah, Dennis Klett. And did I mention Fund, Gunnar Fund? So Aline Kant's Fund model is really useful if you go to voice quality, to the laryngeal signal. And I forgot to mention that the EmoDB is recorded with the electroglottograph. So we did record also the larynx, and that might be interesting also for medical applications. I think would be interesting to, yeah. I need to get to know a doctor, or we need to work more with doctors. I think I have patients wearing these laryngographs and then see whether we can detect sicknesses easier in these signals. That was actually a synthesized signal. Then Matthew already mentioned EmoFill, so that's a tool to simulate emotions. It's based on Ambrola, which is a diphone synthesizer, and again does not sound natural at all. But I can only repeat, I don't think that's a big problem. Actually, format synthesis is still very much liked by blind people because they listen to this super fast synthesized speech, and this can only be generated by format synthesis. So although I guess that deep learning should be able to do that too. WaveNet should be able to do that. But yeah, as far, I mean, in those days, it was only non-uniform unit selection or the old stuff, and the old stuff did still have some applications. So this is based, it simulates emotional speech in 34 languages, which is quite nice. And I had some experiments, multicultural experiments with that. I also did some application experiments. So I emotionalized a fairy tale read by this diphone synthesizer, which is not so much fun to listen to it. And so I asked school kids how they liked it. And to make a long story short, they preferred the emotional style, but they even remembered more facts when it was told them emotional. And I don't think that's a really psychological study, but I would have liked to continue this. I mean, I did most of this work in my telecom days, and I was told I should tell you about the difference in industrial and academic research. And so, yes, you can have fun in industrial research if you work for a real big company. Nobody really knows what you do, and you have time to do stuff like this, fun stuff. So go for Amazon, Amazon Siemens Telekom, so that's okay. You might have fun there. Problem is that it might never see the day of light what you do, and if you don't go out and tell people about it. So I said I did multilingual comparison studies with this emophil stuff because there were so many languages, French, German, Greece, and Turkey. And I'm sorry that
L'extension du parc industriel de feu lui contesté.
That's funny. No, it works.
Journal Le Soir.
So here you have the quality of diphone synthesis in Turkish and Greece. Then together with Björn, we used Emophil to add to the training sets. And actually, I'm still doing this. Sometimes it gives you 2 or 3% more if you add to the training, adding some. With Embrola, you have 6 different voices in German at least. So this is an experiment I did with a team from Björn and his team. There were actually 2 papers. This is one of them, the first one. Then I had this idea, how could I simulate several emotions at the same time? Because that happens, that you win the lottery, but at the same time you learn that your grandmother died, and then you might have something like joy and sadness or so on. It was, so I did this because you couldn't just linear interpolate between 2 emotional states. That does not make sense, not even in intuition. So I tried to mix different levels of features. So I mixed phonation and articulation with pitch and duration features in one voice tone. For example, to have happy, sad. And well, happy, sad was not really detected, but something either happy or sad was detected still. Both. Yeah. So anyway, it worked a bit. Okay, then we looked at, this is more recent, what is an appropriate voice for a robot. As I said, I'm not sure that it always has to be human, and this experiment actually supported this. So yes, the human voices were at the top, but also robot voices, so clearly unnatural voices are appropriate for a robot. And we not only asked, is it appropriate, but how much how pleasant is it for you to listen to this? So Pepper is supposed to be a cute little robot, nothing that frightens you. I come to this project later too, actually. Then I did the Speechalizer. It's still out there. It's still used by me, actually, by me and my students. And I see application for this. If you have to label or transcript or annotate large data sets, large meaning, don't know, 30,000 samples or something, then, and you do it utterance-wise, so not frame-wise, but turn-wise, then that's a great tool to use. I really can recommend it. It runs out of the box in Java on almost every platform. So we did stuff with that. We worked on anger detection. I said that in the beginning, also with Björn together and Yoon and Flo. And it got better with deep learning after 10 years, which is nice, 10% more. But it's not so easy. Then, of course, I often looked at applications. So I had this idea of emotional monitor, actually in my own house with my own daughters, who were teenage daughters in this time, and they quarreled a lot. And I had this little emotion monitor here at our kitchen table. They didn't like it for more than a week, I think. Then I said, stop this. We hate it. And it worked kind of, it works, yeah. So it can detect anger, and then the light here goes red. But it showed me that cross database is really not working yet for me. So I did this with OpenSmile and Veka in those days, and I did it with my colleagues in the office too. But if I cross validated, then it did not work anymore. Yeah, that's chance level. But it did work in its own domain. So now I come to this projects, EcoWeb. What we currently do, that's an Horizon 2020 project to prevent depression with young adults. We monitor, or they monitor the emotions. I mean, the thing is that actually, if you really are in danger to be depressed, you're not allowed to participate in the experiment. So, but that's psychologists. We can monitor emotions, and we hope that some audio expressions now come in. For privacy reasons, I want to show you this. We have to random splice the data, so we don't get the original data.
Das schwarze Blatt Papier befindet sich da oben neben dem Holzstück.
That's an example from EmoDB, and this is random spliced, going back to an idea of Klaus Scherer, actually.
Für mich Wappen neben Strafzeit, wo Adler mit dem Ball befindet sich.
I think it's not that bad. So it does mask what has actually been said without really masking too much what is the emotional expression in this. Then there's another one that's just stopped, OptaPep. It was a German national project to aid psychotherapy with virtual reality and emotional monitoring. So you get in a situation via VR that you usually hate, like speaking in public, and then you get monitored by lots of physical measures and also your voice. And the sad thing for me is that now, as it's done and ready and built, we don't really have data. So that would be interesting. So they gave me some data, but it was just students playing around, and they were not really nervous. So I said, like this, I cannot. Yeah, there's no relation between the acoustic features and the so-called ground truth or the target label, because it's not direct at all. Third one I'd like to mention here is Eric. This is an idea that has been also done with Björn in some projects, so helping autistic children with to process emotional data with the Pepper robot. And here's something we not only do the recognition of emotion in the voice, but also the synthesis using the Pepper synthesizer, simulating emotions with speech synthesis markup language rules. So the normal voice sounds like this.
Hallo, ich bin ein Roboter.
Actually, I had to record this via the air with a microphone. I couldn't get Pepper's voice directly. It's a bit weird. And so if you change speech synthesis markup, so project rules, then you get something like this.
Hallo, ich bin ein Roboter.
And that's how I want to simulate emotions also now in the newest project that we have called Easier. It helps communicate for deaf people with normal speaking. It's a great project, very challenging scientifically, and we also again do the simulated speech synthesis with emotions, and I will use an out-of-the-box commercial synthesizer and use SSML rules for this. I was happy to see that Amazon sells this already on the street, or is doing something that we tried for a long time. They solved it. Yeah, that's a nice video. I think you get the slides later, so you can watch it. And it works. Yeah, in the video it worked well to recognize your emotion via voice. What did not work so well to identify actually the speaker, to really only introduce the analyze the target speaker. And I would be very reluctant to have a microphone listening to me 24 hours, but people are different. So just that you know, lots of what I told you in the last half hour is now can be bought at Aldi, more or less. Okay, this can be bought with us. You don't have to buy it. It is it is from Odering, an Android app, also an app, and you can try this out to say something. Haha, hello. Usually I'm perceived as bored. No, I'm neutral and bored. We can try again. Was? Nein, gar nicht. The model should be better, but we're working on new models, and of course we're always happy for new data. So you're very welcome to use this. Install Vibes on your smartphone and then try it out. Give us some data. I think we're allowed to keep it for about a month or so to learn something from it, and then we have to delete it anyway. Yeah, I think I would skip all this. I was working on likability. So as I said, it's not only about how the speaker feels, but also how do you feel if you listen to the speaker. That's also different, interesting thing. And there's a gender database that we based this on. Working again with Björn and his team, actually long before I worked for Deering. Then I've been working on irony, which Anton keeps saying that he does not believe in this, but I think yes. I mean, of course, irony in the voice is something you can say something ironic, but that's a big field again. Yeah, what is irony? We found some acoustic correlates with ironic speech, but if this generalizes, of course, that's disputable. I'll be the first one who agrees that. Obviously, we also tried machine learning with not so much success, but then it's really difficult data, and it's not much data. We need way more data. There's like so often. That's why this unsupervised learning is important, because going back here, because with these labeled emotion data, you just never have enough. So it's really always super sparse, and so we do need unsupervised learning techniques here. So isn't this emotional technique scary? One of the most well-known examples, I guess, these days is probably China, because they monitor a lot in the public. And even if that would be a healthy democracy, I would be skeptic that that's such a good idea. But there also, of course, to me, this is mainly, I mean, otherwise I wouldn't be working here. I think to me, it's a tool, right? So it's like a hammer. You can kill someone with a hammer. You could save someone with a hammer by putting a nail somewhere where it makes sense. Here, emotional speech is used to detect helping. That's from Fraunhofer, I think. I don't know, it's Washington Post, but wasn't it based on Fraunhofer? Yeah, German researchers. Fraunhofer, there it is. Right. So that's about ethics. So I think you would be safe if you would only work on emotional speech expression if it's in a communicative way used. So there's some authors who said that's the difference between extra-linguistics and paralinguistic. Extra-linguistic would be what would be used for communicative reasons, so voluntarily and consciously, and paralinguistic would be what would be just be there if you like it or not. I just know that this exists with some authors, and perhaps it's useful. I usually call it all the same to avoid confusion. But there you go. If you are in communicative domain, then of course you're safe. You might also be safe in therapy, like I gave you the OfTAP example, that would help people. People would like to have their emotions analyzed, although they are subconscious, yeah. But generally, I mean, I think just follow the rules that, for example, the GDPR gives you, keep the user in control of the data, be transparent that this technology is used, give an option out, consider bias, be fair, explain your stuff, use model cards. I think model cards are a great initiative. It's not so long. That it means really explaining what your model is based on, and giving you, indicating also for lay people, what is this decision based on. So I really would like to, I mean, that's a long shot, perhaps climate change, extinction of species, nuclear warfare are all big problems that we have, and I'm not sure how long there will be humans anymore. But perhaps working on emotional speech can help a bit, not make things worse. I hope, at least for intercultural communication, it perhaps helps. I don't know. Just keep this in mind. I think that would be important. I mean, working so long for a big company like Telecom really gets you thinking. So why am I here? Does it make sense what I do? Yeah, do I need all that money that I earn? So models trained on data. Data is islands. That's the biggest issue that you have is generalization. I guess you stumbled on that problem already. Classifiers are lazy and dumb. Databases different, labels inconsistent. So usually you don't really have a test set because, I mean, you have something that you call a test set and a def set and a train set, but then it goes out, coming back to industry and is used somewhere, and that's that's not the test anymore. Yeah, so you don't really, yeah, these are problems that you have and you have to look at them. You do have, there is a lot of speech data out there, but few labeled data, and that's one example for unsupervised or semi-supervised learning. I know most of you have been working on this with great initiatives, augmenting, synthesizing, pre-training, multi-heading, weak labeling, using latent variables, cross-modal labeling. I think that could be done more perhaps, but perhaps I just don't know all the papers. I guess it's been done already, but that seems to me quite useful. So yeah, video data, video audio data, learn from each other. Then reinforcement learning. I think there's some problems to be solved before. I'm quite optimistic seeing the latest paper. I'm not really sure if it was from Facebook or from Amazon, but they did listen. I think they were learning ASR in a totally unsupervised way, more or less, by self-finding something that relates to phonemes, and then just seeing if this resembles text or not, which comes out. I found that very interesting, and that might be a way for emotions too. I hope I have more time for research in the future. So who needs research if we have deep learning? Isn't it enough to be some engineer and work on deep learning? I'm not sure. Andrew Ng says, I mean, he found it funny. I found it funny that not really are phonemes. Phoneme is something that some phoneticians invented to get paid to have a problem. There's this wave to wake unsupervised. I found that really interesting, so I put it on the slide here. So machine learning made lots of progress. Expert features, expert architectures, are they still needed? That's also mainly targeted to my TU or the Technical University audience, to my students. So what do we do here? If I'm a professor for phonetics, does it make sense to still find something? But I do think yes. So there's ideas to be useful still, be explainable AI, for example. So if you don't know what you do, then there's not much to explain. If you don't have none data at all, or like how would Homo neanderthals have spoken or something, then you would have to model that somehow. That's perhaps far-fetched, but I think that machine learned expert features, for example, do make sense to explain, for example, sicknesses or diseases in speech to doctors. Yeah, you would need expert features, and that could be learned by a machine, but you still would need the experts that actually define the features. And then in medical science, like dysarthria, apraxia, stutter, lisper, and that's here the TAPAS, so you know about this. You have these problems, and so being an expert in these domains, being domain experts, does make sense. So wrap up, natural interfaces are emotion. I hope I didn't have to convince you, I guess, but I think So communication and emotions is heavily related. So it's ethically sensitive by definition. So in a way, emotion is something that you don't want to be really revealed, and so it shouldn't be handled. Emotional categories contrast with other models, more complex. The nature of what is an emotion is totally unclear. So I would suggest be pragmatic and let it be dictated by application, which opens up the problem of how can we learn cross database. Yeah, so if every database is from an own application and they're not related with each other, we would have a problem. So this is only half true here. Deep learning is not a competitor, but it's a big driver. I think I really see this very positive, and we do hope to solve problems. So thanks to all the people who helped me with my life's work so far, and that was my talk. I see something in the chat. Oh, yeah, someone needs to go. Are you still there? Oh, yeah. Can I be heard?
Yes. I'm not sure if I should already enter this. Matthew asked me to take over from him.
Mm-hmm.
And I see he's already gone, so I think I should do so. Okay. The floor is open for questions, please. By the way, I'm Rob van Son, for those who don't yet know me. No questions.
I do have one.
Please do.
So you talk about MODB and all these data sets that we use for emotion recognition, and most of them are based on actor. So it's not real emotion. I just want to know if you know how is the gap between these data sets that are played with actor compared to like a real case scenario, if there is like a huge gap in terms of performances.
Yeah, usually the real emotion is way more subtle and way more different kind of emotion. It's not the big four emotion. Yeah, usually in these acted emotions, I mean, apart from Klaus Scherer really tried to find out which emotions are important in daily life and asked, yeah, you know, he collected 50 words for emotions, I think, and then, but then the Klaus Scherer databases are also very artificial because he let the people say stuff in languages that don't exist, and so yes, I think there's a big gap. So we have to try it. I mean, we have this problem in ordering. That's typical for industry problem because we want to sell our stuff. We want customers. And what do customers do? They take some emotional database that is not by counting 3 on a tree and test our models with it. And so we have to also model these artificial emotions because otherwise they would be disappointed, if you get what I mean. There's about 10 or 20 very famous EmoDBs in the world in Italian, Danish, in US, American, of course, English. There's many of them around portraying 5 to 10 actors and 5 or up to 10 emotional states.
Okay, thank you.
Any other questions? Okay, I have one. You're talking about emotions and the difficulty of getting, say, the real emotions, like the previous question, but that assumes that there is one emotion, but there is actually two. Like in a smile. A smile is one part my internal emotion of happiness or welcoming someone, and the other one is a communicative act. I communicate a certain feeling, and it can be faked completely. And the emotions has these two. There is an internal state we need, and that is unavoidable. And there is the speech that tries to communicate an emotion, not necessarily the one in the real one.
Yeah,
and
totally true.
Now the problem obviously is getting the real one, the internal one.
Depends on the application, right? Yeah,
that's the application. But there's currently no gold standard for the internal state. And an obvious question also, why not ask the speaker? the speaker says something, has you elicit some emotions, real emotions, and then you ask, what was your emotion when you said this?
That's a good point. Yeah, people do this. So there is experiments with that. Like giving people devices, I think little buttons also. So while they are in a communicative situation, they should signal their internal states. There is literature on that. That's not a bad idea, of course. Yeah. I mean, it doesn't solve all your problems. I mean, you already mentioned the main problem is that you would know which emotion is meant, the one you want to signal or the one who's inside you, because inside you there's not only the emotion, there's the mood, there's your personality, all this overlaps. Yeah, and so what is meant. But yeah,
but then,
good point.
Yeah, but on the other hand, for speech technology, for the communicative part, you don't care about the communicative part.
I only see muted microphones here. There's a second screen. There you are, Rob. Sorry, I didn't see you before. I was somehow, I thought, which voice is talking here? Okay, hi, nice to meet you.
If there's still no other questions, there is this, in speech technology, you might, if in a communicative setting, you say, okay, I don't care what the real emotion is. I have to communicate an emotion of the speech synthesis, and I have to recognize what the speaker wants to tell me. So in that case, you could use acted emotions and focus on acted emotion. Then you can get rid of all the problems of the internal state.
Yeah. Okay, my point would be just that the emotions that you would use in daily life communication would be different emotions from you would typically that are in these acted databases. But of course, you could act them. I mean, and this has been done. I mean, all these databases where people talk like IEMOCAP also, yeah, all these databases where students sit together in a room and supposed to discuss something, knowing that they get filmed and monitored now for their communicative emotions. That's nothing else than this, right? So, and you can learn from them, and then it works in similar surroundings. Sure. I mean, I don't see it very negative. It's just But thanks.
Anyone else question? No. I have a remark. That's the last part. Oh yeah. So you say, Gauri?
Yeah. Hi, Gauri here.
Hi, Gauri.
Hi. I had one question about analyzing emotions in a conversation. So emotions are highly dynamic in nature. So what is your opinion on considering what duration of speech signal should be analyzed for labeling an emotion?
Yeah, that's also a very good point. Yeah, I think up to now it's been difficult enough to recognize the emotion. So what actually is the target of the emotion? If you hint at that, so aspect related emotion detection from voice has not been looked at much. I mean, this is well known for sentiment analysis, right? Text-based analysis. What is actually the target of the emotion expression here? And it would be the same, would be true for emotion in the voice. So as far as I know now, what is being done now is either you analyze every 100 milliseconds or something, you do a continuous emotion level, something like a level meter, or you go utterance-wise. And in a dialogue situation, of course, you would go turn-wise. So, but the question, what is actually the target? And I think this also relates to Rob's remark before, that it's very fuzzy what is what we measure and what is the target. So or the event. What is it? Yeah. So how would we handle this? And we cannot handle it intelligently if we don't even model also what is or detect what is it about. Very good points. Yeah. But good for us that there are many problems left. If you look to Google videos, also I sometimes saw Amazon. I think okay, all is solved, no problems anymore. But then if you think a bit more about it, then you find there's lots of questions.
Right.
Anil, you want to ask?
Just a quick question. Hi, Felix. Really engaging presentation. Thank you. And I was fascinated by the a piece that you meant. The little device that you put in the kitchen with your daughters, and I thought that's brilliant. I love these kind of fly on the wall kind of experiments. So first question there was, did that actually correspond to them getting cross with each other? And maybe the follow-up on that is, now that we've got all these devices that are 24/7 doing what you've done many years ago, is there sort of a feedback loop that you could make, or do you know if there is research that's doing that feedback loop to say, yes, it was I was getting cross with my partner, so on and so forth?
No, I didn't work long enough now, to be honest. Didn't so it did detect the anger, but only if it was acted again, to be if it was full blown. So these 80% was really very clear anger. And it didn't run long enough to see if it was useful or not. It was actually one of the ideas. So if you meet in a commercial or professional situation, you meet with someone and you have a dispute or personal with a partner, and then you could have just put your smartphone on the plate and say, no, let's talk. And you're angry. No, I'm not. Here, see, my smartphone says yes, you are. Stuff like this. This has been actually used in Big Bang, so in TV series. That's a good idea. So if it works, if it's useful, I would be perhaps skeptic, but it would be fun to try it out, definitely. Yes.
But your thinking would be that self-certifying your own emotions is not a good plan.
Possibly too, yeah.
Okay, no, thank you.
Fascinating. There's lots of super fascinating questions go with this, because the way we interact, I mean, machines analyze how we are, but us interacting machines, making us more machine-like, of course, because we learn too, not only the machines. And this goes too for emotional technology. So, yeah.
Thank you.
It's really a fun topic to work in.
Other questions?
Yeah, so hello, this is Florian from Augsburg speaking. So
Hi.
First of all, thanks a lot for your interesting talk and for giving us this insight into the world of automatic emotion recognition. So my question is rather a higher level one. So obviously lots of research has been done over the last decades in this field. However, interestingly, there are not too many applications used in our daily lives so far. So what do you think could be the reasons for this, and what do you think could be the most realistic emotion recognition related application scenarios that will be established in the next decade or in near future?
Yeah, I think, I mean, it goes back to the one slide that I showed in the beginning when we tried to find answers for use cases. So what do we do if we detect anger in a voice portal, for example? And we found out that we couldn't do that much because the machine was not intelligent, couldn't handle it really in a sensible way. Yeah. So I think, to me, a nice example is always gaming. And I'm really happy that Ordering is doing great progress now with contacting game companies, and we have a game product now out there, a Unity interface. Because I think it makes, I mean, also with my experience with children, reading them fairy tales, it showed me, and I think it makes sense, that information gets more interesting, becomes more interesting and fun if it's emotional. Yeah, if it's so I would go in this approach, actually. And I mean, I do hope that there are medical applications, but then perhaps less for emotion, but more for something like Lisp and Stutter. And I think it would be good to have some feedback on the way you talk, the way your speech is perceived might be interesting for lots of use cases for people to get this analyzed in a general sense.
Thanks.
Welcome.
Any more questions? it seems we have finished for this this morning session. So does Sao want to tell us something, warn us something yet, or the other organizers for the next session?
I think it was a big honor to speak here and was really lots of fun. Thanks for your questions. Nice to meet you. And I hope to see you soon over a beer or something in life without Corona. Bye-bye. Have fun.
Bye.
In case you need anything, you're very welcome to contact me, right? So it's easy to find me on the internet. Bye-bye.
Hello, Rob.
Hello.
I don't know. I can't send any message to you. Not sure why. Okay, whatever. For the afternoon, yeah, we will start at 2 o'clock.